Adjacent, opposite, and hypotenuse. You already know where the hypotenuse is, right? That's the side across from where? The right angle. That will never change. Now what we're going to focus on is, so we're going to start with angle A. So we're going to focus on angle A right now. What I need from you is, where is the opposite and the adjacent side? All right. What side is opposite angle A? What side is adjacent next to angle A that's not the hypotenuse? All right. So we already know the hypotenuse. That shouldn't be an issue. That's AB. How about the side opposite angle A? Name that side that's opposite angle A. Here we go. Okay, I'm not going to wait today. Opposite angle A, CB. And what's the side adjacent to AB? AC. When I say adjacent, I mean a leg that's adjacent, not the hypotenuse. Can you guys do the same thing now, but turn your focus to angle B now? Tell me the hypotenuse, opposite, and adjacent side while looking at angle B. And those would be what sides? 7, what sides? That would be adjacent, correct? Yep, keep going. Still, that doesn't matter what angle I'm looking at, and there you go. Any issues with those? I will never have you go from the right angle. Anybody know why? If I said what's adjacent, what are you going to tell me? Could be either two legs, right? So we will always go from one of the two acute angles. All right, we'll focus on never from the right angle, okay? All right, can you label the diagram now? So now you're going from angle R. Can you guys mark the hypotenuse, the opposite, and the adjacent side going from angle R now? And you'll see why we're doing all this in a second. Okay, what are those new sides now? Here you go. 4, what are my new sides? Yep. Yep. All right. So we're not having, anybody having any trouble identifying those? Because I'm going to bring these up again in a second. Adjacent, opposite, hypotenuse. Questions? All right, I'm about now to introduce you to 3 brand new ratios. All right, these ratios are called trigonomic ratios. All right, that's on the front of your notes there. All right, 3 brand new ratios. Let me introduce them to you. Before I introduce these new 3 and how do I say them, what's it short for, etc., I just want to point out this little new symbol here you'll start to see. Looks like a circle with a little horizontal line through it. It's called theta. It's a Greek symbol. All right, it's used for angles. So remember last problem here? I had angle R. I could also call that angle theta if I wanted to. It's a variable. Okay, X, you guys are very used to using X and Y. All right, this is just another variable that usually is used with angles. So if you see that, it's a variable. All right. Let me introduce you now to the 3 new ratios. The first one is not called sin. This is an abbreviation for sine. Okay? Sine ratio. How do you find the sine ratio? You take the opposite side over the hypotenuse side. That's why I've had you find all those at the beginning of class. All right? So this is called sine, but it's abbreviated SIN. Next one is called cosine, COSINE, and we abbreviate it COS. If you guys are asked to find that ratio, it's going to be the adjacent side over the hypotenuse side. And finally, tangent, abbreviated TAN. All right, abbreviated TAN, you take the opposite side over the adjacent side to find that ratio. Now that's a lot to remember. It's not on a formula sheet, unfortunately. So how do we remember what cosine equals, sine, etc. equals? Anybody familiar with the movie or cartoon, whatever, I don't know what, animated film, Pocahontas? Yes? Anybody know a quick fact that she had a brother? Pocahontas had a brother. All right. His name, Sokotoa. All right. His name was Sokotoa. All right. Pocahontas' brother's name was Sokotoa. And this is how he spells it. Looks like you're going to do some Googling later. I know. You can call me out later if you need to. All right. This is how he spelled his name, Sokotoa. It will help you remember how to set up the ratios. Watch how he uses his name. The S in his name stands for sine. And how do you find sine? You take the, what's O? Opposite side and put it over the hypotenuse. The C, cosine. How do you find the cosine ratio? Take the adjacent and put it over the hypotenuse. And finally, how do you find the tangent ratio? Take the opposite side and put it over the adjacent side. Nice little device to help you remember what goes over what. All right, Pocahontas' brother, Sokotoa. The only problem some of you may run into, spelling it correctly. Okay, spelling it correctly. All right, but it's a nice little device. All right, so let's use it. All right, I'm not going to go through the steps. Let's just get to a problem. Let's use it. Find each ratio as a fraction, and can you cross off this because we don't have time, as a decimal to the nearest. We're just going to find it as a fraction. I know everyone could type it into their calculator and find it as a decimal. All right, the first ratio I need is what? The sine ratio, but it's got to come from what angle in number one? B. So everyone take a look at angle B. There's our focus. And might be a good idea, let's all write Sokotoa up above. So we're not flipping our page back and forth here. I'm looking for what ratio again? Sine ratio. So according to Sokotoa or your packet in the previous page, what's sine equal to? Opposite side over hypotenuse. From what angle? B. Ready? We'll do this one together and I'll start calling out people. What side is opposite B? 15 over, where's the hypotenuse in this diagram? Okay, I do need to go over this because I know some people don't know. The hypotenuse is across from the right angle. We all good? All right, across from the right angle, 17. So the sine ratio for angle B is 15 over 17. Let's go to 2. Now I'm looking for the tangent ratio from W. So everyone focus on W. Tangent, according to Sokotoa here, is what? 10. Yep. Sine, cosine, tangent. So it's going to be, I don't want to know. I just want to know opposite over adjacent. Now I'll ask somebody else. What is the opposite side to W? Here you go. It's going to be a long day. 17. 10 over the adjacent side. 13. Adjacent means the leg, not the hypotenuse next to it. So 10 over 13 is tangent W. Cosine T. Cosine T. Well, first of all, let me know what cosine is equal to. What's that ratio, cosine? Executive decision. 15. Adjacent over hypotenuse. Here we go. 3. What's adjacent to angle T? 15. And the hypotenuse in this diagram across from the right angle? 39. 15 over 39. Tangent of W. First of all, tangent ratio. Here we go. 16, tangent ratio.
Opposite over adjacent.
Good. 5, what's opposite W?
3 radical 6.
And what's adjacent?
3 radical 3.
All right. We know we're not leaving that like that, huh? 3 radical 3, sorry. Hold on. 3 radical, there we go. You know we're not leaving it like that. What do you think we can do? Okay, I can cross out the 3's, yep. So what am I going to be left with? Radical 6 over radical 3, okay. Anything else you think I can do here?
I'll multiply that by radical 3 over radical 3.
Okay, I'm going to go a little even shortcut here for you, Will. All right, you're right. I can't have radical 3 in the denominator. Are both numbers under a radical? Okay. Can I divide those numbers underneath the radical? 6 and 3, can I divide those? What would it be? Okay, so it's going to be equal to not 2, but radical 2. Yep, if they're both underneath a radical and I can divide them. All right, so radical 2. How comfortable are we here identifying opposite, adjacent, hypotenuse? Okay, because here's what I just told you at the beginning of class. I'm going to give you an angle, a side, find another side for me. Okay, that's where we're going right now with all this. And then where's the calculator come in, which is coming up now. All right, here we go. Find this missing side. All right, let me go through the methods we've done already. You tell me why they're no good. Why is Pythag no good in example 1? I don't have all 3 sides. Why is not the 30-60 or 45-45-90 rules good here? It's not that type of triangle, right? So I'm stuck until now. Now that I have SOHCAHTOA in my belt. Also, I didn't mention SOHCAHTOA only for right triangles. That's what this whole unit's been about. All right, only can be used in right triangles, not any triangle. All right, so here's where we're going to start. We never go from the right angle. We always go from an acute angle. What acute angle is given there? 36. So everyone focus on the 36. What would be the 15 then? Hypotenuse, opposite, adjacent. Opposite. So what I like to do, what I would recommend you do as well, is in parentheses, I just put a little O there to remind me, hey, that's the opposite side. What other side is labeled? X, AB. What is that acting as in my diagram? Okay, so I put a little H there to remind me, hey, you got the hypotenuse too. I do not touch the blank side. Just going to confuse me. Don't touch the blank side. So what sides do you have? Opposite and hypotenuse. So if you go up to SOHCAHTOA and you ask him, hey, what should I use if I have the opposite and the hypotenuse side? He will tell you to use sine, the S, right? Because these go together, SOH. You have opposite and hypotenuse, so I should use sine. Okay, so we've determined I'm going to use sine, the abbreviation, SIN. We're going to set up an equation now to solve. Anyone questioning right now how I know it's sine versus the other two? We have opposite and hypotenuse. That gives me the sine ratio. We all good? Here's the adjacent side to 36.
Well, why is it like? Oh, all right. So it's from angle B.
From the acute angle that I give you, which is 36. Right? I'm given the opposite side 15, the hypotenuse, which is x. All good. Everyone else clear here before I write the equation, because this is a whole different ballgame now. Okay, to write the equation, the sine of what acute angle? Because we always write in the angle. All right, but now I know what it is. What is it? What's the angle? 30. Hold on. Let me back up. Remember, we always went from tangent of W, cosine of T. Well, now, I'm not going to put the sine of B, because I know what angle B is. What is it? So I'm going to put the sine of 37 or 36. Thanks. Here we go. Much better. What's the sine ratio equal to again? Opposite, which was what? 15 over the hypotenuse, which we labeled as x. Now is how the heck do you solve that now? So I got to get x by itself. Well, let me throw it out to you before I show you how to solve it. Anybody get x by itself here? What's that? Here's what we're doing. Hey, this is really over what?
1.
And what is this? Yeah, we've been doing it all year, right? This is a proportion I can cross multiply. So help me cross multiply. 15 times 1, yep, equals sine of 36, which is a number, and your calculator will do it in a second, times x. Now how do I get x by itself? What should I be doing on both sides? What's happening between these two right here? Multiplying. So if I want to send the sine of 36 to the other side, I should probably divide. Yep. Not by 36, but by sine of 36. That gets the x by itself. Now all I have to figure out is what the heck is 15 divided by sine of 36. And that's your calculator's job now. Okay? Before you do anything, don't get ahead of me here, champs. You need to make sure your calculator is in mode, degree mode, because that's 36 degrees. If it's in radians, which we'll talk about later on in the year, change it over to degrees, please. Or you'll be like, why am I getting no answers correct? Make sure it's in degree mode. Everyone in degree mode? And what are we trying to find the value of? 15 over